Let's have a look here, Amjad, make sure the sound's working. Yep, sound looks like it's working. Okay. So like I said, we'll have a look now at page 34. You said or, wasn't it? Okay, so 34 now. So we have, rather big one here actually, 75x4 minus 440x cubed plus 657x squared plus 33x minus 408 all over 75x cubed minus 440x squared plus 832x minus 512. Well, the first thing I need to do is long division. Yep. So, long division first. Probably will have to zoom out now to fit this in. 75. Would you be smart enough if I didn't write down x cubed, x squared, and x and just wrote numbers down, that you'd know what I'm doing to save space? So we have 75x cubed minus 440x squared, 832x minus 512.
Sorry.
Andy, could you make any more noise coming into the room? Goodness sake. Why is it not clear? Why confused? Why is this confusing? Is these four numbers not the same as these four numbers? And you have imagination? So you can imagine x cubed, x squared, 8x and no x here. And if you can't imagine that, then write it in. I won't think anything less of you. Right. 657, 33 minus 408. So, 75x cubed and 75x4. So what would I need here? I need x. So that would be 75x4. Well, notice what happens. It looks like I get just this. Okay. And then I subtract. Well, the x4s go, the x cubes go. I'm just left, oh, and that carries down as well. I'm just left with 657 minus 832. Can you do that, please? 657 minus 832. Minus 175. And then 33 plus 512. 545 minus 408. So to finish, oh, this is interesting now. Is this why it was difficult? The x4s cancel. The x cubes cancel. Now I'm with x squared. Yes, but I'm trying to think what number I need here now. Maybe. No, that's it. Yeah, no, maybe that's it finished now, actually. That's it finished. That's the remainder there. Or maybe not. Yeah, no, that's it. Yep. I know it seems a bit weird, but if you think about it, how do I know when to stop? Well, if I divide a cubic into power 4, the answer should be linear. Like if I divide a linear into a quadratic, the answer is linear. I give you an example here. If I divide an x squared, a quadratic, into an x6, the answer at the top should be an x4. Why is that? Well, if you think about it, this, remember, multiply this, has to make that, plus a remainder, yeah. So in other words, if I divide a cubic into a power 4, what should I have left on the top? A linear, an x. I shouldn't try to continue anymore. This is my remainder. So now I have 75x4 minus 440x cubed plus 657x plus 33x minus 408 equals x times 75x cubed minus 440x squared. I'll need to go to the right. Plus 832x minus 512 plus the remainder, which is this, the remainder here, minus 175x squared plus 545x minus 408. Yeah?
Isn't that x squared for 657 on the left side?
Yes, it is. I didn't get the square when I wrote it. So, x times that one plus the remainder. That's what I have on the right there. Now, what's normal to do next is you divide everything by the cubic there. So when you divide the left by the cubic, no surprises, like in every single question, we get back here the original question. Because remember, well, you can't quite see it there, but this here over the cubic is the original question. So I divide everything by the cubic now, and I get back my original question equals x over, oh no, just x, because that's gone, and then plus, and now we have this piece here, minus 175x squared plus 545x minus 408 over the cubic. 75x cubed minus 440x squared plus 832x, whoops, minus 512. Now, Amjad, what is the denominator like there if you try to get the answers? Now, check on the calculator. Abdel as well. Is it 1, 2, or 3? 2. So one of them's repeated then. Okay. So this is equal to x plus, okay, what's the first one?
3x minus
3x minus 8. So the answer on the calculator must have been 8 over 3. Yeah, what's the next one? 5x minus 8. Ah, now this is interesting, because it's not entirely clear which one gets the square, because they both do the same thing. They both make an 8 squared, which is 64, and I'm sure 64 times 8 is 512. So I need to look at the fronts instead of the backs. So I need 75 in the front. So if I square this one, I'd get 9 times 5, which is no good. But if I square this one, I get 25 times 3, which is 75. So this one gets the square. Yes. If I square this one, I'd get 9 times 5, which is 45. No good. But if I square this one, I get 25 times 3, which is 75. So this is the one that gets the square. Now, like I said, in the exam, in this weird, I know here should be a linear, but it's a special type of linear. So we can have a peek at the answer, because in the exam, like I said, they'll tell you which one is the 0. So if I have a look at the answer here, I see that there is no x. So it'll just be ABC. A, B, C. What do we do next? Well, the next thing is, we know the next step. We multiply by all these three things here. Oh, well, in other words, by this cubic here. So on the left, we'll just be left with, like normal, the x4 part. 75x4 minus 440x cubed plus 657x squared plus 33x minus 408. I don't have space here. I'll write it underneath. Well, equals A. Zoom out again. Well, I'll zoom in. On the left there is just the x4, which is in the question. So on the right, you put in your three brackets, so you'll be left with, that cancels, 5x minus 8 squared plus b times 3x minus 8, 5x minus 8, so 5. And then finally plus 8. C, 3x minus 8. Yep.
That's it. The web didn't have C. We have only A and B.
It just means when I do this, my B will come out as 0. Yeah, that's fine. That does happen in the exam as well. One of those. Don't be surprised. I've seen that happen once or twice in the exam where one of those turn out to be 0. So there's nothing strange there. Okay. Right. What?
Is that the going to find?
Sorry. Yeah, here.
This is not the quadrant minus x.
What?
Minus 175.
70. It's 75x4. Yeah.
I mean, not this.
Oh. Do I have the wrong thing there?
No, I just it's the wrong thing. You have to solve this, not the first.
Oh, yes, you're right. Thanks, Andy. This isn't here. I should have been. I'm looking at this. So when you multiply by the denominator, the cubic goes and you're left with the quadratic on top. That would have saved pain later. 75x squared plus 545x minus 408. Okay. Now, what value should I take for x first? 8 over 3 looks good. So let x equal 8 over 3. And then this will give me out the A, because they will go. Then if I say let x equal 8 over 5, that's an 8, they'll go. This will give me the C. And then to finish, I can do anything for the last one. I just say x is 0 maybe, or can I cancel these? No, sorry, I want the B. I can't, yeah. Let x equal 0, and this will give me the B. So, can somebody check with me as well? So, on the left, we put in 8 over 3. So, minus 175, 8 over 3 squared. So I got on the left minus 172 over 9, and then divided by 5 times 8 over 3 minus 8 squared. Yep, I get A is minus 7. Is that right so far? It is. Now, the fact that I've got the first one right means that the other two are going to be right when I do it, because I mean, it'd be very unlikely that the first one is by accident the right and the others then work out to be wrong. So I'm sure when you put in the x is 8/5, you get the correct answer for C, which will work out to be -5. And then again, I'm sure when you put x equals 0, you'll find out that B needs to be 0. I mean, you can check these on the calculator, same way I did that, okay? And then that's it, finished. Yeah. Sorry, I was a little unclear earlier. What you're doing now is you're using proper partial fractions on this problem. So it's a new problem inside of the original problem. So we actually use this now as the numerator and this now as the denominator. And then when we have our ABC, we put the answer back into this line. Not forgetting the plus x is what I'm saying. Is there a plus x? There is, yeah. I know it's tricky, but I hope now it's starting to get a bit easier, okay? So you wanted as well, Amjad, an example from integration, or anybody as well, if there's any particular one you want for integration of proper partial fractions. I don't think there is a U. Oh, Q. Q? Amjad, did you have one in mind, or you just want to see one? Anybody else? No, improper integration will be done in a moment. I'm looking at page 36. So what do we think? Will I just do Q? Yeah? Q? Okay. Mohammed, why are you talking in my class again? Do you have a question for me? I'm starting to think I should have you sitting separate from the rest of the class, because you cause a lot of distraction for me. Would you like to sit separate from the rest of the class? No, that'd be worse. Just be quiet, okay? If you have a question, no problem, just ask me, okay? Alright, so look at the next one now. Q on page 36. So, fraction. Q, 19x squared minus 48x minus 291 over 5x cubed minus 57x squared plus 139x plus 105. Right, let's have a look at what the denominator gives us. So we have a 5, a minus 57, a 139, and a 105. Good news is it has 3 roots, so that makes things a lot easier. So we have a over the first one, which is, I think 5 it was, let me check again, 5x plus 3, plus b over x minus 7, plus c over x minus 5. Alright, like before, we will multiply everything by this denominator here. The 3 factors, that is. 19x squared minus 48x minus 291 equals a. X minus 7, x minus 5. Plus b. 5x plus 3, x minus 5. I need to go over here to the right. Let's zoom out. Zoom in. Can you see that there? That's a 3, not a b. Plus c, 5 x plus 3, and then x minus 7. Okay, so what will I do first? Let x equal 5. So that goes, and it gives us the c. Alright, let's check this now. So 5, okay. 19, you can check 2. I'm putting 5 in. Minus 48 times 5. Minus 291. And then, what did I say? 5, so that's 28 there, and then 5 minus 7, minus 2. So after all that,
1.
What did you get?
You get 1.
Good for you. Right, next one. Let x equal 7. 19, that squared, minus 48 times that, minus 291. 5 times 7, 35, plus 3, 38. And then 7, the first one and the last one goes, and 2, 4. Okay, so here it gives me b equals 4. Okay, now the last one I'll just put let x equals 0. So I'll get minus 291 minus a, which I don't know, sorry, minus b, which is 4 times 3 times minus 5, and then minus c, which is 1, and then 3, and then minus 7. That's minus 210. And then I'm looking for the a, divided by 35, and I got minus 6 for the a.
Why is x minus 0 minus 3 over 5?
Oh yeah, that would have worked as well. Give you the same answer. Let's pretend we did it that way. Minus 3 over 5. You get x is minus 6. Sorry, I was thinking of the last question again. Okay, so we got our A, B, C. So now here I can put in A, B, and C. So A is minus, actually I'll put it in a different color as well. A is minus 6, B is 4, and C is 1. So if I want to integrate this, it's the same as integrating these 3, which is handy. The reason that's handy is because these 3 are in the formula book. If you open up your formula book, you have a rule for, well, you can take the 6, 4, and 1 out. You have a rule for 1 over ax plus b. So I'll write up the top here. This can be written as minus 6, 1 over 5x plus 3 dx, plus 4, 1 over x minus 7 dx, plus 1 over x minus 5 dx. And like I said, this is in the formula book. The first one will be minus 6 over 5 log 5x plus 3. Guys, the formula book is online as well if you ever need to use it in class. Just print it out, okay? This is in the formula book. Plus 4 log x minus 7. And then lastly, plus log x minus 5 plus c. And that should be the answer. I hope it is.
Could you
Zoom out, yeah. Now what do you need to see though?
Perfect.
That's fine? Okay. Steve, there's a 6 here, okay?
It's negative 6, right?
Negative 6, yeah. Well, have you got your formula book? No. You should print it out and bring it to the next class, okay? But you can see there are formulas in the formula book for integrating these fractions. We did it in semester 1. Bring the formula book. If you don't remember all the formulas, which is okay, you are only human after all, just bring the formula book. Yep, formula book. It should be clear from the formula book, okay? But you need to bring it to class if you're having trouble remembering them, which is okay because you can use it in the exam. Okay. What are you looking at there?
News.
Give me. Maths news, right? Yeah.
You have to plus C and TS, right?
Yes, yes. Plus C is there. Okay, so we'll go on now to the next topic, which will be the end of the integration until the next chapter.
I don't think so. The next chapter is
Trigonometry. Okay, what's wrong, Abdul? You want to die, do you? Let me see. How difficult? Let me think. Totally difficult. I shall. H. Yes. 1H. Super difficult. Okay, so if you look at page 38. Okay, 38, I'm going to do H. We're missing now Amma, as usual. Shaban, which is starting to become usual. Who else? Anybody else? Yeah, Hong, yes. Those three. Mohammed is his usual thing to do is to be late. That's his usual thing now. And being kicked out is becoming quite usual as well, yeah. You know, everybody has their thing. Amjad likes to ask questions. Andy likes to cause trouble. Abdal likes to look confused. You all have your own thing, you know? Like cartoon characters, you know? Everybody's different. Okay, next one now. H. So, please pay careful attention. It's a long question, but there's no one part in it that we haven't done before. It's just a matter of putting all the different parts together. Okay, so let's start off then. Well, I'll write the question down first. 104, no, sorry. Write down, right first. 10x4 plus 7x cubed plus 44x squared minus 94x minus 134. Sorry, that looks a bit messy. That's 134. Well, anyways, it's the question. You have it in front of you. All over 5x cubed plus x squared plus 22x minus 72. Now, before I started, just make sure I wrote that down right. Otherwise, it's going to be a long day. Okay. 10x4 plus 7x cubed plus 44x squared minus 94x minus 134. All over 5x cubed plus x squared there. Plus 22x minus 72. Okay. Well, what do we do first in these improper situations? Long division. And what type of answer am I expecting from my long division? No? Linear. So, first my long division. 5x cubed plus x squared plus 22x minus 72. 10x4 plus 7x cubed plus 44x squared minus 94x minus 134. So first thing I would need here would be 2x. That would make 10x4 plus 2x cubed. 5x cubed plus 44x squared minus 94x minus 134. Well, the only thing here is 1. 5x cubed plus x squared minus 22x minus 72. Now I know I need to stop here because I have my linear on top. So my remainder will be, well, that's just going to be, I'll do it in red to make it stand out a bit more. That's going to be 43x squared. And then we have minus 94 plus 22. So that's minus 72x. And then minus 134 plus 72. Yep. I'm tired and hungry. That's my defense. Don't worry, I know you all write slow, so nobody could have gotten to that part yet. Alright, 2x cubed plus 44x squared minus 144x, is that right? Alright. Actually, that's not so much better, a little better. They subtract. I'm left with 5x cubed, gone, minus 94 plus 144, plus 50x minus 134. Okay, is that okay now? And then here again I still need the plus 1. So I have 5x cubed plus x squared plus 22x minus 72. And then subtract again. Okay, well, those x cubes, they go, there's a minus x squared here, 50 minus 22, so that's 28. X, and then 1 minus 134 minus 72, so minus 62. That's the remainder now. Yes?
X cubed.
Yeah.
And x, there's no.
I think you meant the word x squared, was it?
Yeah.
Yep. You're right, there is no x squared above, so it's no x squared minus x squared. Minus x squared. Too much Arabic, that's why the vocabulary is a problem. Isn't that right, Mohammed? Maybe so, yes. Okay, so continuing on now. So we know now that this here is equal to this cubic times this linear plus this remainder. So if I go down now, my question, which one was I? Which one did I say I was doing? H, was it? All right. So my question, I'll just write Q for question. No, I'll write the whole thing out. I won't be lazy. 10x4 plus 7x cubed plus 44x squared minus 94x minus 134 equals 5x cubed plus x squared plus 22x minus 72 brackets 2x plus 1, and then I need to add the remainder in here. I put it in red actually. Minus x squared plus 28x minus 62. Alright, what I do next is I divide by the cubic. So when I divide here by the cubic, I get 10x4 plus 7x cubed plus 44x squared minus 94x minus 134 all over 5x cubed plus x squared plus 22x minus 72 equals 2x plus 1 plus minus x squared plus 28x minus 62 over the cubic as well. 5x cubed plus x squared plus 22x minus 72. I'm not feeling good about this cubic. I'm feeling like it's going to have one root.
Yes.
Oh, no, don't say that. So the first root is 5x minus 9, and yes, one root only. So we know what we need to do now. I'll just give you a minute to catch up. Yeah? Mohammed, did you write this down?
Yeah.
You've written all of this down. Did you write all of this down?
Yeah.
Really?
Yeah.
So if I look, I will see everything there in your book. Oh, good. That's surprising. Yes, okay. Right, can I continue now? So then what we do as a side problem is we look at this one here. And what type of problem is this? Partial fractions. So to the side. I can't quite get it in the corner. Well, you get the idea. So when I look at this now, I'll write it here. Tell you what, I'll even give it its own box. Okay, so when I write this here, I'll just write Q for question. It equals A over the first root. What did I say the first root was? 5x minus 9. But this cubic has only one root. So what does that mean the other root is? Very good. There's going to be a quadratic here. So if there's a quadratic here, what goes on the top? Yeah, bx plus c. Now how do I find the quadratic that goes here? Oh, I feel the energy in this room right now. So yeah, long division. Well, hang on, sorry. Oh no, that's right, sorry. Plus x squared plus 22x minus 72. And what do I divide into it? The factor I have there, 5x plus 9. So firstly, I got x squared. So here I get 5x squared, 5x cubed, sorry, plus 9x squared. When I subtract, what am I left with? Minus 8x squared plus 22x plus 72.
Isn't it 5x minus 9?
Hang on. Sorry, is it? Oh, that should be a minus. Yeah. Just change that. Just change that plus there to a minus, and here to a minus. So then that means here is a minus, which makes that 10 instead of 8. Okay, what number do I need next then to make 10x squared? If I have 5x? plus 2x. So then I get 10x squared minus 18x. Okay, and I subtract, that would be 22 minus 18 is 40, yes, 40x. I'm trying to squeeze this in too much. 2x by 5x is 10x squared. 2x by minus 9 is minus 18. The 72 comes down to 4. Okay. Yeah, no, that's it. Sorry. 40x plus 72. So what do I need to finish? Oh, sorry. My minus turned into a plus. So what do I need to finish here? 8, I think. If I have an 8 here, 8 times 5, 40x, and then 8 times 9, 72. So the remainder will be 0, which is exactly what you want. So I have my answer. The quadratic that goes here is x squared plus 2x plus 8.
So the question ever give a remainder?
You mean in this situation here, if I got a remainder, it means I did something wrong. It should not be a remainder here. It could be a remainder at the other part, but not for this. It's a mistake if you get a remainder. Okay. Let me sharpen up my pluses and minuses. So that's a minus there, remember. So what do I do next here? Well, I multiply. You got to imagine this is down here. This is equal to that. So what do I do next? I multiply everything by this cubic here, and I'd be left with minus x squared plus 28x minus 62 equals a times x squared plus 2x plus 8 plus bx plus c times 5x minus 9. I'm feeling like comparison method today. Unless comparison method, or anybody have any strong opinions against that, except MB? You prefer let x? Alright, let x. So let x equal 9 over 5 first? Okay, and that will give you the a. What is it?
Minus 1.
Thank you. Let x equal 0. So that b is gone. You know the a. Do you already have this? Yeah.
Equals 6.
6, good. Okay, and then to finish, what did you do?
B 0. X equal to 1.
Let x equal to 1, and what did you get?
B equals 0.
Okay. B equals 0. We've seen that previously. So then if b is equal to 0, that means there's no... Oh yeah, there's no b in the numerator, no x part. Which I think is a good thing, actually. No, because the 8 won't be 0, it'll still be 8. And the c won't be 0, and the 9 won't be 0. The reason for the choice of 0 is to cancel the b. The a you already know, so that's why it gives you the c. Yeah. Okay, so now we have our a, b and c, but b is actually 0, which is great. So I'll go back up a level. So that was the here. So this here is that, but remember the b is 0, so that's actually gone. So my original question here, that's equal to 2x plus 1 plus a. What was a, Andy?
Minus 1.
Okay. Minus 1 over 5x plus 9. Sorry, I'm jumping around here. Let me zoom out a bit. And then plus, what was the c?
6.
6 over the quadratic. And what's the quadratic? What was the quadratic? X squared plus 2x plus 8. Okay. So if you want to integrate this, it's the same as integrating all of this, which isn't actually as difficult as it looks. The first one, what's the antiderivative of 2x? No, antiderivative. The takamo. You know? I'm speaking Arabic here. You know takamo? Sorry, my pronunciation's not so clear. No, right. You know what I'm talking about? Yes. So, 2x antiderivative? You speak Arabic? Yeah. You know this word? I like it actually, the anti-camel. Yeah. I'm picturing some kind of like Arnold Schwarzenegger blowing up camels or something. The anti-camel. Alright. Antiderivative of 2x is x squared, yes. The antiderivative of 1 is x. Now, Amjad, this again is in the formula book, okay? It'll end up being minus 1 over 5 log 5x minus 9. But this here is a problem. We could try the substitution method, but like last time, we'll see that fails. There's actually a special thing you're supposed to do here. If anybody remembers, please tell me. What could we try to do here for that one? U equals what though? Well, before even U equals, there's something you should do. Complete the square in the denominator. So if I complete the square here, I'd end up getting 6 and then x plus 1 squared plus 7. Yes, that's it. X squared plus 2. Yeah, that's it. So I really have to do a side problem. So I'll go back to the side now in a minute. Okay, so just make note of this now. This is a side problem. So to the side now. I'll go back to this, don't worry. So as a side problem, I have 6 over x plus 1 squared plus 7. What do I let u equal to here? Square root x plus 1 squared over 7, which will end up equaling x plus 1 over root 7, which is 1 over root 7x plus 1 over root 7. So what does du dx equal? 1 over root 7. So this equals 6 over, well, this will be, when I substitute this in here, x plus 1, that'll be 7u squared plus 7, and then my dx is root 7, yeah. Dx is root 7 du, so there's a root 7 here as well, du. So this will end up being 6 root 7 over 7, 1 over u squared plus 1 du, after you do your substitution. So what do you get here? Well, that's 6 root 7 over 7 tan inverse u, which is x plus 1 over root 7. Like that. So far, so good, I hope. Yeah. Alright, so I'll just give you a minute to write that down, and then we go back to the main question. So there's only one line left. This topic here was on the lesson integration of simple rational functions we did a couple of lessons ago. Okay, did you write that answer down there? Where? After tan, that's tan inverse. No. The u is this just. No square. That's a square there. Anyways, back to the question. Can I scroll across now? Yeah. So going back to the question. Zoom back in. So, no need for a question mark here anymore. I have the answer. Let me make some space. So it is, what did I say, plus 6 root 7 over 7 tan inverse. Hang on, need more space. X plus 1 over root 7. Yes? Plus C. Now, that's what you call an integration problem. But the nice thing is, in terms of your revision, this lesson, hey, listen carefully. This lesson on page 38, to do it, you need to have page 32, 4, and 6. So, in fact, in terms of revision, you only need to do page 38, not 32, 3, 38 includes all the previous problems as sub-problems. In other words, if you can do 38, it's only because you can do the previous 3 worksheets. Okay? And if you can do this question, if you can do my questions in the workbook here, you can definitely do them in the exam. And if you think about it, this chapter now can be broken down . So if you want, just for a moment, can you turn to page 24? And I just want to give you some advice here. So on page 34, can you tick the title, put a tick beside the title. And then page, right, did I say 34? I meant 24. Put a tick beside the title. Then 26, put a tick beside it. And then 28. 30, and then all the way skip until 38. Put a tick beside it. So you see, everything in that chapter is represented in those worksheets. So I mean, when you're doing revision, you don't need to look at the entire chapter, because a lot of the chapter was building up to this final topic in the chapter. Okay? So it is literally like the last 3 lessons, which we must have spent about 5 hours on, plus more, was just preparing you to do this one type of question here. Now, this is the most difficult type you could get. In fact, there's a good chance in the exam it won't be this difficult, but it could be this difficult.
In that case, we avoid it, right?
Yes, but you see, the thing is, it depends how the rest of the chapters go for you. So usually what it ends up being is students either do this question in the exam or the vector question. Have you done vectors before? This is a new word for you, vectors? Yeah. Have you done physics before? No. Okay. You might not know this word then. Anyways.
Speed of the distance, right?
It's related to that, yeah. A vector is like those little arrows that point in different directions, yes? Now, so I don't forget, let me think. Well, firstly, if you're asking me which ones do I need to do, if you can do, like on the other worksheets, K down to T, not only, if you could do K down to T, not only can you do this worksheet, I'd say you could do the previous 3 as well, okay? So I'm going to give you, make this class a double then for this topic. So I'm going to give you time to work on these. As you can see, there are long questions. They take some time to do. And also, so I don't forget, I'll tell you now so that you can have lots of time to do it. So you have another homework for Monday of next week. So in other words, in 1 week's time. So you've done all the question 1s from the revision book. That is on chapter 1, the differentiation. Question 2 in the exam is on the second chapter, which is the functions. You remember the one-to-one, onto, range, the modulus function, the graphs, the transformations. Remember all of this? And if you can do all the question 2s for me for Monday, okay? There's about 10 or 11 of them there about that, okay? I know that sounds like a lot, but if you break it up, you could do 1 a day, and then you could maybe do 2 a day on Saturday or Sunday then. The question should take you about, it shouldn't even take you 15 minutes to do. At most 20 minutes per question, okay? But really, you should be doing it in 15 minutes, I think. Because it's not like the question 1, which were longer. Question 2 is actually shorter. It's a bit quicker to do, okay? So write that down somewhere if you are liable to forget, which is most people, that I want all the question 2s from the revision book for Monday. And for now, you can be working on the improper partial fractions. And while you're doing that, I'll upload the video from last week.
And
Lesson on this one, integration. Yes? Okay.
and the answer.
Huh?
And the relation answer.
I think they're already there. I'll check.
Another check.